Okay, testing. Is anybody else there? Hello, are you able to hear me? Are you all able to hear me?
Yes.
Yes.
Is everybody?
Hello. Sketchy hedgy.
Well, okay then. So I pulled a presentation up and I'll send a presentation after this is done. So our session is on combinatorics, and since binomial theorem is related, I decided to include that in as well. And yeah, so there's the fundamental counting principle. It basically means that if your event if your event is getting from A to C, and so if they are as shown as in this diagram, if there are 3 ways to get from A to B and 2 ways to get from B to C, then the total number of ways to get from A to C are 3 multiplied by just 3 multiplied by 2, and you have to get either from A to B or either from B to C is 3 plus 2 in this case, and well, that sounds simple enough until you had muted them. So permutations permutations are ways of arranging things when order doesn't matter and doesn't pose restrictions, and combinations are ways of choosing to get things together when order does pose restrictions. So you
Wait.
Yeah.
Isn't that not the opposite? Or am I tripping? I thought permutations was when the order matters.
Yeah, permutations is order
So-
matters with permutations.
So there are like restrictions, right?
Yeah, there should be. I think that was a mistake.
All right, I'll just clarify. Okay, thank you.
For me, when I take an example, then like it works better. Like I try to put it verbally. So if you're choosing like if you're choosing 3 objects from six, then we use like permutations when we care about which particular 3 objects, which order they are in. So yeah, maybe. And wait, I'll get how to get the annotation. Yeah, I put it. In case of permutations, the formula is like and for combinations, it's like so the difference is between the respective formulae arises from that if they are n factorial means that they are like total n objects, and when you're taking the combination instead of permutation, you actually like it doesn't matter whether whether something particular is in this position or this at the first or the third position. It just matters that they're chosen, and so that's switch from. So I have like a couple of questions which are not like based upon actual problems, but they're just to like kind of get comfortable with uh, the formulaic part of and yeah, combinations also have this property that clear combina combinations also have this property that n c r is equals to n c n minus r, and you can see why that occurs, because like when you input this and when you so these are just equal, you can see like n and n cancels out, and these are the same. So this is one of the properties of combinations, and which is why we may see that like binomial sequences are like symmetric. Okay, switch to screen. Yeah, so let's just like do the couple of problems given, and yeah.
it might be useful to just put the formula, so I'll just draw it.
Yeah. Uh, uh, so how is everyone doing on this question? I think I should have started with a different question and then moved on to it.
I'm also not sure on how to equate the actual combinations together, to be honest.
I actually kind of almost got it. I already found the two equations.
Yeah. And did you try to solve them simultaneously?
Not yet. Still trying to figure it out. Like still midway.
Yeah.
So should I go through like a couple of easier examples first, and then we could go over to this question and then.
Okay.
Okay, so try this one. N P R is equals to 360. Try one thing. Don't try to expand the expression you get after you you write down the formula for permutations. You have to find and
Yeah, you're supposed to find n. I think I'll give a hint to do with factorials. So obviously, you know, factorials just like the multiplication of all the previous numbers. So if you have something like n factorial, that's the same as n minus 1 factorial multiplied by n, which is also the same as n minus 2 times n minus 2 factorial. Let me just erase that. Times n minus 1 times n.
yeah, I'm gonna say yeah, like I said, don't. There's a trick involved. Don't expand, otherwise you'll get like a quartic equation. You have the trick involved is basically involves the fact that the after simplifying the left part a bit, the numbers involved are like continuous, are like consecutive numbers, and the right side you have to find factorize the right number into something that is like which consists of consecutive factors.
Yeah, that could work as well.
uh, I'm going to start working out this question because it's not supposed to take a lot of time. It just needs you to understand the hint you could the trick you could say. So as you know, like permutation involves uh, n minus 4 factorial, and you have 360 on the other side. Now to simplify the left-hand side, we know that we can also write it as n minus 4 factorial times n minus 2, 3, n minus 2, n minus 1, and then n minus 4 factorial is equals to 360. We can cancel that off, and then we aren't if you expand this out, I don't think it would be like get any easier to solve it. But what you have to notice is the all of these are consecutive numbers, and uh, so you can factor out 360 and find out such four numbers which four consecutive numbers which get you 360. So if you do 45 times, and this is going to be 3 and 5. So we factored 360 into with the eraser, yeah. So we have factored 360, and as we saw, it becomes 5 times 2, 945, 90. Yeah, 5 times 2 cubed times 3 square. Now, in order to figure out what these 4 factors could be, you could use the fact that one of them will, you can see that one of them has to be 5 because uh, and then you have to look for numbers surrounding 5. 5 is like uh, if we include 5 in and with another of these numbers, then you won't be able to get like something consecutive because it's comparatively big. Then you could get below than 5. You have 2 squared would get you 4, and then 2, and then 2 times there's a 2 left and a 3 left from here, so that would get you 6, and then and you get 3. So you can also write the factors as 3 times 4 times 5 times 6, and then you can notice that how it matches up. And you can see that it all fits if you place in n is equals to 6. So that was like the trick involved, and I think in the slides you could. The second question is rather similar. You could try that one, and provided that you know how to, yeah, provided this trick. So are we able to like get the second question, because like it actually has the same answer as the one I just did.
Yeah, I was gonna say, can we express the expression as n choose 4?
Yeah, because of the identity.
Yeah, you just said in the beginning.
Mhm.
Really cool.
Yeah.
I'm gonna write that down actually. Hold on.
Okay, how about the first question?
Okay, we'll go over that one together.
Okay. This, I was like working on the first question all along, and I could find the equation, but not the N and R.
Usually in like IB questions, you have like two consecutive coefficients, but not like three consecutive coefficients but given. Like either N and R is given and you have to find just one of them. So this is a step further. Did we get the second question?
Isn't the answer the same?
Yeah.
Okay.
Yes.
Yeah, that was a coincidence, really.
There are no coincidences. That's a lie.
Well, so it's you're given three expressions. NCR minus 1 is equals to 36, and CR is equals to 84, and CR plus 1 is equals to 126, which is a lot, but yeah. So so in order to evaluate that, I'm going to write. I'm going to simplify that. This on this side we have r minus 1 factorial n minus r plus 1. That will on this side we have n factorial r factorial n minus r factorial on this side, and n factorial r plus 1 factorial, and n minus r minus 1 factorial. So we are going to take two of these at a time, but I'm going to take this one with this, compare this one with this one in order to get a ratio, and compare this one with this one to get a ratio. The reason why we are not comparing the first one and the second one is because the cancellation would, when you like take a ratio and do the cancellation, it will not it will give you a harder question, like when r plus 1 factorial divided by r minus 1 factorial would get you r plus 1 times r. But if you do r plus 1 factorial which is here, and r factorial, you would get just r plus 1. So this is the difference between solving like a linear equation and solving a quadratic. So I'm going to remove the second. I mean, not the second. That's the most important one. The third equation for now, because we are working on just the first two. We can divide both these equations by each other. So we get 84 by 36 equals to n factorial and minus r factorial, and this is being divided by the upper expression, so it becomes n factorial and minus r plus 1 factorial and r minus 1 factorial. We can see that a lot of stuff is going to get cancelled. Over here, r factorial is just r times r minus 1 factorial. So that is that we can cancel off. And then this is just one more than the above again. So we get n minus r plus 1. Now we can just cross multiply, that is multiply both sides by 36r to get like a linear equation. So if we multiply by 36r over here, we would get 84r, and if we multiply by 36r over here, we would get 36 times n minus r plus 1. If we simplify that, we are going to get 84r is equals to 36n minus 36r plus 36, and then we take all the variables to one side because that would help us get compare when we get another relation. Now we are going to save this thing for now, and we are going to get another expression in order to compare to and thus get n and r. So our second expression was n c r plus 1 is equals to 126. Now we can write that out. Now once again we are just going to divide both the expressions. So if we divide 126 1 by 84 and you divide this thing, so the n factorial cancels out, and this should come up on top, and r factorial by r plus 1 factorial, the bottom would cancel out, and you'd get just fractions. You'd just get r plus 1, and then on the top then on the top you'd get n minus r through a similar cancellation, and then you'd get n minus r by r is equals to 126 by 84. Then I'm going to rub the middle part now. So it someone's 126 r is equals to 84 n minus 84 120. Wait, something's wrong actually. Oh. I'll check my my own working of this earlier. How great did you all get? Because I faltered a bit doing it directly on screen. And yeah, I showed the question. And factorial. N minus r factorial. And over here we have minus r minus 1 factorial, r plus 1. '84 by 36 is r and minus r, and then
Don't you get like a ratio of 1 to 2.5, I think? Like between n and r. And then you can just substitute it in from the previous thing that you've shown.
so you got like yeah, that would be a valid method to do, but did you get the final answer?
Oh no, no, not really. I didn't have the time to write it all down, to be honest.
Yeah, it's a
Um,
pretty long question.
I
I
found
was
the
not able.
algebra, but I can't solve for R or N. Because, yeah, I did find the ratio of it.
Yeah, I worked it out earlier, but wasn't able to find my work on it. And yeah, doing it directly on screen, you make more mistakes.
Let me try
I
again.
can go through. I can go through it quickly if you guys want.
Yeah, I think this is where I made a mistake. 120.
Wait, I've got the answer. I can go through it.
Okay.
Aaron, can you switch to the whiteboard, please?
Okay.
Okay, so we've got like the 3 combination equations. So instead of having it as a fraction, I'll just multiply both sides and make n factorial the subject for all like the equations. So you get n factorial is 36 times r minus 1 factorial times n minus r plus 1 factorial for one of them. And then for the second one, you have n factorial is 84 times r factorial times n minus r factorial. So what I'm going to do is just equate both sides. I'll introduce the third equation later. So now we can do some cancellations with factorials. So we know that n minus r plus 1 is greater than n minus r. So we can express that as n minus r factorial times n minus r plus 1. And same thing with the r factorial. That's just r minus 1 factorial times r times n minus r factorial. So obviously this cancels and this cancels. So you end up having 36. Or let's say 3 if you divide, or if you simplify. 3 n minus r plus 1 is equal to 7r. So you can just expand now. So 3n plus 3 is equal to 10r. So that's the first equation. I'll write it down here. Now, if you work with the second and third equations, so you have 84 r factorial times n minus r factorial, and the second one, so again, same thing. I'm just going to equate them and try to find common factors. So we know that n minus r factorial is the same as n minus r minus 1 factorial times n minus r. And we know that r plus 1 factorial is r factorial times r plus 1. We can just cancel this and cancel this. And then you get 2, oops, what did I do? You get 2 n minus r is equal to 3 r plus 1. So 2n minus 3 is equal to 5r. Just going to erase all of this. So now we've just got two simultaneous equations to solve. Which is pretty easy. I'm pretty sure everyone can do that. And if you solve these two together, you would get that n is 9 and r is 3. Did that make sense?
I had to do the simultaneous equation twice.
Sorry?
I had to do the simultaneous equation twice
Ooh.
to find, the, because at first you will only get the ratio of n to r, so you gotta do it again to get one of them.
Sorry, what do you mean?
Because to get the answer, you need to find the ratio between n and r. And then after finding the ratio, you have to insert the ratio again to find, wait, did I overdo this? Oh, I might have overdone it.
How did you do it?
So basically what I did is I did the simultaneous equation thing, which gives you the ratio of n equals 3r. And I think
Right?
instead of inserting it back to the equation, I decided to insert it back to the combinatoric formula
I
itself.
see, yeah.
So the entire thing
Yeah.
becomes really long.
Yeah, that overcomplicates things a lot.
Yeah, could have inserted the simultaneous equation thing.
Yeah. I mean, if you just have two linear equations, that's pretty easy to solve. So that was a nice question.
Yeah, I really liked it, to be honest. Where's it from?
It's from the.
Oh, he just got his sources.
Yeah, it's in the sources in the which I've placed in the server. So okay, I'm going to talk about. Yeah, I faulted a bit while explaining permutations and combinations. I would actually take an example. So suppose you have 5 objects. Let's just call them A, B, C, D, and E. Now, if you could just repeat them, repeat all of them, and place them in 5 positions, it would be just 5 to the power of 5, because you from the counting principle, because you can place anything from A to E in the first place, and from A to E in the second place. But when you're not allowed to repeat, then when you're not allowed to repeat, it just becomes 5 factorial, because the you can place anything from A to E in the first place, and in the second place, you have reduced one of your letters, and then again you further go on, and from just a counting principle, you the factorial expression appears up, and then now suppose you're asked to choose three. Yeah, drawing tool. So you're supposed to ask uh, three how to choose how many ways you could choose three of these is and there's one case where it matters whether it is A, B, C, and or uh, or C, B, A, and there's other case where this doesn't matter. Uh, so the the first case is permutations, and the second case is combinations. So you can see that the difference between the formula of permutation and combination is just that there's an an r factorial on the bottom, and the rest is similar. This is because you look at ABC, and you see how many ways are there of just rearranging ABC amongst itself. Since there are three letters, you can rearrange them three times, and that is what basically your R factorial is. Uh, then you're supposed to pick three of these from five letters. So in the first place, you could get anything, any of those five letters. And then you have reduced one of your letters, so it becomes four, and then again you have reduced one more letter, so you get a three. And then again you can see where the combination expression comes from. If we are good, so this is the same as 5 factorial divided by 5 minus 3 factorial. Uh, you can see where it all comes from, because you're supposed to select 5 3 objects from 5. So you get this expression, and whether or not the arrangement matters or that's what the R factorial determines. Yeah. Okay. Clear all drawings. Well, the next slide maybe was some actual questions concern. Yeah. Yeah. So this is a particular type of. So the next question, five questions. We'll do only some of those, and at the moment, this is a particular type of permutation question where you have objects sitting around in a circle. So uh, the boundary conditions are that like they could be swapped each other with each other, and it doesn't matter. So it's like one less than that. Uh, I would actually want you to give a try to. Well, the first question seems fine, so just give first question a try, and if you get it, it shouldn't take a lot of time. We would go over it then. Yeah, and don't give attention on the first. I mean, this question. We look to the factors question later. 6. A suggestion is that if you are not able to uh, get with a round table, try to think of it as like a line. What if the people concerned were being arranged around in a flat table, and then in- and then think of bringing it around to a circle. Uh, Then you have to consider the boundary condition given that is any two and only two of the ladies sit together.
Wait, are we supposed to do all the questions?
Did you get the first one?
Yeah. I did.
What did you get?
54? Not sure if that's correct, but yeah.
I haven't checked the answer of this question, so I wasn't sure.
You
So
want me to show the solution? I guess.
yeah. So, three ladies and three gentlemen. I guess we are concerned with who those they are particularly are. So we have to consider their order. Now the condition given is any two and only two of the lead is set together. So in such cases, what we do is we consider the two ladies to be like just one, and then there's also the fact that they could be rearranged themselves. So you have to make sure you're multiplying with multiplying by 2, and then you have to arrange them with a man and with 3 men. And notice this arrangement won't work, because when we make a circle out of this, like uh, the 3 could just come together. So we are going to end with a lot of such cases. So the best is to just find the cases where like all of them are together, and then subtract it off. So when all of them are together, this we consider it to be we consider 4 objects, because we are like we are kind of lumping all of the 3 into one. And then there's also that you can rearrange these 3 amongst themselves in three different ways. So there's that. And in this case, you have 5 people in all, and you can rearrange rearrange these to any how you like. So we get 5 times 2 factorial. And then I'm not sure how to take care about the boundary condition now. I think it's just like when we take all these cases, there's one case where yeah, so I think it's just 5 factorial times 2 factorial minus 4 factorial times 3 factorial minus 1. We are subtracting one case because of this particular case I've drawn here, which when we wrap it around a round table, this won't work. So we get 120 times 2, which is 240, and then 4 factorial is 24, and 24 times 6 is 144, minus 1 is equals to 95. This is what I'm getting, and there are like a lot of conditions in this question. So I may need to check. Did anybody else get an answer for this question?
I guess I did. Wait, what's the Oh, I didn't get that as the answer.
What didn't you get? Why I was
I got
subtracting one?
I got 54.
You got 352.
No, I got 54.
How did you get 54?
Wait, where is it? Since the question says that any two and the two ladies, I kind of grouped the two ladies into one. So like I kind of assume that there's 3 groups. Wait, let me check my paper again. And then so that's that is for the positioning it's 3C1. I think that's incorrect. But okay. And then after that I do where did I get 3 times 2?
So
Just
you
too
done?
big
Okay,
brain.
for some reason I decided that it's a good idea to multiply 3 times 2 times 3C2. For 3C2, I think that's to decide for the chances of the ladies, because it's between 3, it should be like either 2 of them, which I don't think is right.
Can I just go through the logic that I went through? I got an absurd number, by the way. So, how do
Should I
the
switch to
second?
whiteboard?
Can you? Yes, please. So what I've actually done is I've drawn the cases, right? And you get something like this. And so we get that there must be a girl here. It must be a girl here. There must be 2 boys separating them. And there must be here either a boy or a girl. Like in here, like the order does not matter. Or boy.
Oh,
Or
it's all
girl.
okay. Yeah, okay, now I get why. I thought it was like 4 people. That was my mistake.
So what I've done here is now, like, correct me if I'm wrong, like completely, but I've taken the fact that all of these girls can be actually be arranged in 3 factorial ways, and so can the boys in total, right? But I've also said that since we're talking about a particular order here, I said that we are seeking to do 3 choose. Oops, sorry, this is really off. Just a second. I said 3 choose 2 twice because we're deliberately choosing 2 of the seats, which is the girl and which is the boys and the girls in here. And then for the other one, since we can have a boy and a girl, and if I was to take into account, for example, by choosing that this is like a boy and a girl, I just times it by 2. Right? And this, and now I'll talk about the rotational symmetry. So this can go 1, 2, 3, 4, 5 before the fact that we get a girl and a girl here again. So I times it by 5 as well. Yeah, and that's it. And I get an absurd number, which is 3,240.
Oh God.
Sorry. But I don't know whether this makes it at all.
Hetty, did you get
Talk about the fact that about arranging girls and boys, like choosing them here. But then again, I'm like, we could technically speaking choose any girl. So I'm just thinking that the arrangement of ways still has to be 3 factorial. And same with the boys. And given the fact that we can take either boy or girl here, and then we can rotate these people 5 times around, like it just makes sense in my head, but I don't know whether it's correct.
No, it's definitely not correct because 6 factorial is 720. So it has to be less than that, right?
But like, I mean, true.
Oh Lord, combinatorics again.
Dude, I hate this. Like,
I mean, after like attempting to redo it, this time with like this thing, I did it like how Sam did, except without the 3 factorials.
Is it without the 3 factorials?
I don't know, because I feel like I'm lacking something, but then again, I have no clue.
The thing is, like, I feel like I'm confusing the fact that I arranged the girls and boys. But I think like if we give the pre-boundary conditions in which they have to sit, we definitely have to times it by 5 because we can rotate them 5 times.
Yeah, I did multiply it by that. I think that's plausible.
And also times 2 because in here it can either be a girl or a boy and a girl. Because like in here the order actually does not matter.
I found the answer key and it was 72.
God
And,
damn it.
Oop, nice.
72.
So what they are saying is the number of selection of two ladies to sit together is 3 choose 2. That is your choosing from the 3 ladies which 2 ladies are going to sit together, and then let the 2 seats of occupied by these 2 ladies be numbered as 1 and 2, and the remaining seats will be 3, 4, 5, and 6. The third lady cannot occupy a seat 3
And 6.
and 6.
Yeah.
So this one's occupied by the ladies we are grouping together, and these 2 cannot be occupied by the third lady. And so there are only 2 choices, either 4 or 5
Yeah, exactly.
left, with the third lady who can make the selection in 2 choose 1 ways. Now
Which
in
is
the
timesing by 2. Okay.
because from the 2 positions you're putting in one lady. Now the 2 selected ladies can be permuted in 2 factorial ways, so they can be changed in 2 factorial ways, and the 3 gentlemen can be permuted in uh, three ways. So this goes, I mean, the 3 factorial ways, Now by product rule, that is, we get 2 factorial from the fact that the 2 ladies are being permuted together, 3 factorial from the fact that the 3 gentlemen are being permuted with each other. 3 choose 2 because we're selecting the 2 ladies who will sit together, and then you get 2 choose 1 because you have to choose which 2 remaining seats the 1 lady goes to, and you get 4 times 6 times 3 choose 2 is just 3, and then you get 20. This seems off. This still seems off. Let me see. Yeah, the logic seems right, but they have written 72. It looks like it should be 144 actually. It looks like there's a mistake in the booklet, but yeah, the logic seems all right. Okay, we're switching back.
Wait, hold on.
Yeah.
I just input that in my calculator and I get 72. Why are we getting 144?
Oh, you missed a factor of 2.
Wait, 4 times 6 times 3 times 2.
Yeah. 72. Wait, what?
144.
Yeah.
Oh, but hold on. It's because I put whatever you had on the top, which is the 2 factorial times 3 factorial times 3 choose 2 times 2 choose 1. And I got 72. What in the world?
I
Just a
guess.
second.
Yeah, there are a lot of boundary conditions. There are a lot of conditions in each of these questions. I think there are the least number of conditions in question 4. So I guess we could do that next. Find a number of ways that 8 beads of different colors be strung as a necklace.
Oh. Mm. Wait, so do we use all the 8 beads?
Yeah.
Oh. And the colors are all different.
Yeah, of different colors.
Oh, that's easy then.
Did we get an
Yeah,
what answers did we get?
8 factorial.
8 factorial would have worked if we were arranging them in a line, but in this case, we are we are arranging them around together in a circle.
Mm. 8 factorial times 7.
Is anybody still working, or should I explain like the working out of this?
I'm cool with you explaining about it. I don't know for others.
Usually in when we talk about circular, so we have 8 factorial ways of arranging 8 beats in a line, but when we wrap it into a circle, there's also the consideration that if there's bead A on this side and there's bead B on this side, it it doesn't matter if bead B comes to this side and all A comes to this side. These two situations will end up being the same when we wrap it around a circle, and that total number of 8 situations like this where this could occur. So it it goes 8 factorial divided by 8, and then there's another consideration. There's a consideration with symmetry. Uh, so if it's it erase with symmetry. So if it's a factorial over, I mean object A over here and B, C, D, E on this side, or whether they go to this side, it doesn't matter. So in the case of circular permutations, we have to like divide it by 2 again. So your end result is you can simplify 8 factorial by 8 easily. That becomes 7 factorial, and then 7 factorial divided by 2 is 20.7 by 2 C60 equals to 21. Yeah, this is the final answer you would get. So did you understand why we divided by 8 and 2?
Can you explain on the 8? I understand the symmetry.
So if you are in case of circular permutations, when you arrange them all in like a line, and then you make your calculations. In this case, you got 8 factorial. If we label those A, B, C, D, E, F, 1, 2, 3, 6, G, and H. Now it's not going to matter if it's going to be H, B, C, D, E, F, G, A. These two will end up being the same thing when you consider the fact that it goes around in a circle, and this is this may not be, the middle part may not be the same. So this does not like get covered by symmetry. And there are a total of 8 situations, such situations that they could occur like this. Um, so since there are 8 since there are 8 letters, there are 8 so you divide by 8 and then there's the symmetry.
Okay, yeah, I get it.
Should we
Okay.
try another question involving just circular permutations, or we just relegate that to later and proceed?
How much time do we have? I think it pretty much depends on that. How much time we have.
I'll send I think all of our time would be expended if we do the rest of the questions. So I think we had rather proceed because
Okay.
there's the binomial theorem. So, okay, so over here we have like actual IB pasta people.
Yes. Okay.
Wow.
That was so much harder.
Okay. Yeah, these are pretty easy.
So I say we are going to do. We are going to do the this part and the check our answers after 5 minutes or so.
This is supposed to be non-calc, by the way.
I'm like, why
Oh,
are
yeah?
there so many marks for this?
I mean, true. Yeah, I got it.
Okay. Okay, did we get the answers? What is
I think so.
uh,
I got 46 for 1A. You guys get that?
No.
I got 70.
Thunk.
I also got 70.
I probably did it wrong then.
Did you do 8 choose 4?
No. Because, oh yeah, we can just do that. Yeah, that would work. I tried to do like each different combination separately. So like 4 girls
Oh
and
Lord.
1 boy. Yeah.
Dude, I just pray to God that we don't have much, like we get like a 5 mark or 6 mark question number 1 combinatorics question.
Well, they're not that common in IB papers. Like some papers don't even have any combinatorics questions. So
It's good
I pray.
knowledge though.
Part B is just 68 then, right?
Yeah, should be.
Really? Oh
I
my
think so.
god.
Because you just
4
subtract
choose
the
4.
cases.
Yeah.
So, oh yeah. My bad. 60. Wait. 68. Right?
Yep.
Okay.
And did you get 288 for the second question?
I haven't gone through that. Which second question?
3 girls and
The 3 girls and 4 boys.
Oh no. I didn't start. I thought we were only doing the top one.
Oh,
Yeah.
4. What did you get, Hachi?
288.
They're asking you to find the probability, right?
Oh, probability. I misread. Oh, it should just be, let's see. Seven. You can use a calculator for this. 0.0571.
I don't use a calculator. Is that the same as 2 by 35?
Yeah, it is. Nice.
Okay, I got the 3 girls and 4 boys one. That one's easy.
I'll put the third one in the Discord chat.
Okay.
What did you get as a probability again?
0.0571 or 2 by 35.
Huh?
Is that not what you got?
Wait,
No.
Which one?
The 3 girls and 4 boys.
Oh,
Because what
I
I
got
did is just,
Oh shit. I did question number A. I didn't know that was like a separate question.
For 3 girls and 4 boys, I just did like 2 times 3 factorial times 4 factorial.
yeah.
And that gives you 288. Yeah. That was easy.
Alright, let me do that then.
And
I
then
did
you
A.
just divide by the total number, total possible combinations.
Oh, okay. Oh, it's final probability.
Yeah.
Yeah. Yeah, got it.
Why is this question so isolated? If that makes sense, I guess.
What do you mean?
Like you wouldn't usually find like a question like this isolated from a paper. Like, how many marks would this be?
This one is 4 marks, I think. Yeah.
And is that it? Like the only question that was in the paper, like for that part?
Yeah. I've never seen like 2 combinatorics questions being asked, like full questions.
Oh, that is so sad.
And I've never seen a section B
Wait,
combinatorics question.
do we have combinatorics in AA or AI?
Oh shit, good
Uh,
question.
Just,
I love how
I
you
mean,
guys know it even if it's not in the syllabus.
For me, it
like,
is.
I wouldn't mind learning about it, but it's just like, is it in or is it not? Just
I'm curious. I'll just check the
as
syllabus.
a. Because
I mean,
like, if I remember, for some reason they didn't have it in. Yeah, for some reason they didn't have it in AI, but I don't know for AA.
For AA, we have like combinations, yeah, and permutations.
Oh, you do have it.
I don't think AI would have it. It wouldn't make sense.
Why?
because
I mean,
it's so
I
much
would
important
assume it's.
probability.
Well, I would assume it's like a part of applications, since it's.
Yeah, exactly.
Yeah.
Plus, I
It's
think
like,
it's got like a big amount of interpretation into it because the amount of ways you can solve this shit is insane.
Oh yeah.
I thought this is like supposed to be AI, at least to some
To be
extent.
honest,
Apparently
yeah.
not. That is
It is
weird.
in AA. I'll have a look at
Mhm.
AI now.
It's an HL. Wait. The HL section of, I think, numbers. Yeah, number and algebra.
Yeah, that's the first topic.
They're just so weird. I don't get it. But okay.
Yeah, honestly, you guys say that we're lucky, but I think we're unlucky.
I mean, I'm starting to like gradually regret more and more on my choice for AI, but it feel like that sometimes. I just feel like there's like way more resources for AA instead of AI, so it's just easier to study.
I'm regretting because of paper 3, to be honest.
Okay, so you guys have to do eigenvectors as well.
Is that how you pronounce it?
Eigen, or is it eigen?
I don't know.
I had even a weirder pronunciation, but forget about it. I'm really bad at
Oh
pronouncing
my.
stuff. I'm like Igen.
Wait. Oh my. Eigen.
Yeah,
My teacher says eigenvectors, so that's how I
Again.
pronounce it.
Yeah, I don't see permutations in topic 1. So I don't think you guys have it.
Wait, AA doesn't have eigenvectors?
No.
No, we
Oh
don't.
no, I'm talking about, yeah.
Yeah.
We don't.
I do know
They
that.
barely,
Mhm.
I think
I
there's
do.
barely any vectors or matrices in AA.
Yeah, we don't
Is
have
that
any
right?
matrices either.
Oh wow. Do
Yeah,
you do
matrix
basic
is.
vectors at least?
Yeah, we do
Wait,
have vectors.
there's matrix algebra. What does that mean? Oh, but it's just like.
Oh, like, is it one solution, infinity solutions, or no solutions?
Yeah, it's only like the tree solution of unknowns and stuff.
Yeah, I mean,
And it's for H also.
I kind of forgot that. I think it was infinity solutions when all equal to each other, right? Like all of them formed a straight line, in a sense, like a similar. Okay, never mind. Just forget it. I'm mumbling.
Jeez, the new curriculum is so weird. Like, it's just, I don't know. It's not. To some extent, it's ridiculous.
The probability was 2/35, right?
Yeah.
Yes.
Okay, cool. Are we gonna do the other question?
Sure, if you guys want.
Okay.
All right, let's do it. I think Hetchy already said, but if you want to see the full question, I think you put in a sessions chat.
Yeah.
Did not format this properly.
Oh boy, we're not even halfway through.
Oh boy.
Oh shit.
Okay, time to speed run this thing. If that's even possible. Okay, I think I got the answer for A.
What did you get?
Okay, got on.
Okay, are we all done?
Yeah.
I'm done.
Yep.
Okay. What did you guys get for A? I got 0.4047, etc.
I got 34.
I got 34 as well.
It's just number of sections, not
Oh,
the
it's not asking for the
probability.
probability.
No.
No.
Oh, fucking damn it.
It's okay.
How much did you get again?
34.
Okay.
Okay, yeah.
For the second,
I'm on it.
has everyone done the second?
I'm doing
Typing
it.
I mean. Oh, okay.
You get 21? No, wait. That's not right.
I got 42, but I'm not sure. Did you get something different?
You get 1 of 5.
I got 126.
Mm-hmm.
Does that even make sense?
Why would it be 126? That's the total
Really?
number. Yeah, 9 choose 4, right?
Oh wait. I think I made a mistake. Oh, I got 84 now.
Oops.
That's weird, but okay.
I still have 42. What did you guys do?
All right, so Aryan, could you switch to whiteboard, please? So I took all the possible combinations, which is 9 choose 4, and I subtracted all the combinations in which there are 1 or 2 odd integers and the rest are even. So 1 odd and 3 even, or 0 odd and 4 even. So 1 odd is just 5, because there are 5 odd numbers, and 3 even would be 4 choose 3. And this gives 20. And then 4 even numbers is just 1, because there are only 4 even numbers in the set. And if you do 126 minus 20 minus 1, you get 105.
I see.
Pretty sure that's correct, unless I did something wrong.
Could the 4 you got odd plus 4 even as 1, like could the 4 evens be like rearranged among them?
No, because it's combinations, so the order shouldn't matter.
Yeah.
How do you all get your answers?
I did something super wrong on this one, so don't worry about it.
Okay. Are we doing the next question now? Or?
Yeah, sure. If you guys got time, I don't mind.
Wait. Okay.
Oh, for mine, I did two even, two even, two odd, three even, one odd, and four even. And then I just add all of them together.
I see. And did that get you a different answer? This one's really nice, by the way.
Mm. It's so tempting to just answer it as 12 factorials.
Mm. Yeah, it should be 12 factorial.
Wait, really?
Yeah.
Okay. I found all the answers, but I'm not sure if I'm correct.
Okay, done.
All right.
I think I might have found the answer, but they're all very ridiculous.
Yes,
Oh,
they're
boy.
very high.
Okay, so the first one is self-factorial. That's easy. Part B, did you guys get 18 times 10 factorial?
18 times what? Sorry, come again?
Sorry, not 18. 16 times 10 factorial.
Yes. Whew.
Okay, nice. Chelsea,
Wait, what?
you get 16 times 10 factorial.
Wait, what's the answer
Part
for?
B.
Oh, okay.
580 is
Okay.
608.
16 times 10 factorial, same.
Yeah, okay. And part C should be 12 factorial minus 18 times 10 factorial.
Did you say 18 again? Or am I tripping? 18 times 10 factorial.
Hmm. Oh,
Why
Okay.
18?
I did 3 times 2 times 3 times 10 factorial.
What did that give you?
I think that no, I tried something and the answer was different.
Okay, I'll explain. So basically, I found all the
No.
ways in which
Oh,
there's
I get it.
they're seated next to each other.
Mm-hmm.
So in one single row, there's either desk 1 and desk 2, or there could be desk 2 and desk 3, or desk 3 and desk 4. So that's 3 in each row. Multiply by 3 for 3 rows, that gives you 9. But then you could also have it such that you could also have it such that either Helen is in desk 1 and Nikki is in desk 2, or Helen is in desk 2 and Nikki is in desk 1. So they could interchange. So you multiply by 2. And then you obviously multiply the rest of the students in the 10 desks, the permutations, which is 10 factorial. So these are all the cases in which they're sitting next to each other. So you just subtract that from the total.
Okay, yeah.
Okay, I just missed interchange of.
Wait, but
Yeah.
but if you do that, now that I think about it, it also includes when they're sitting in different rows. Because in the question they say like specifically in the same row.
Yeah. So we do consider that.
Or
So they're basically looking for all the ways in which they're sitting next to each other in the same row. So for each row, there are 6 different ways for that to happen, which is a total of 18.
Do you understand, or because
okay.
I think if we annotate it, it'll be better.
Yeah, feel free.
Because
Hmm.
so we could have such possibility that they sit here, and they also sit here, right? So that means we have to multiply our answer by 3. And then we consider that they're a single object, basically. And they can be interchanged like here and here, for example. So we just have to times that by 2. And then since this can happen in 3 different rows, we can also times it by 3 again. And since we can interchange the rest of the 10 students, it's times 10 factorial. Writing with mouse is hard.
Yeah, that's also how I did it. But I feel like there's something wrong about it.
Basically, you consider the ways in which they sit in different columns. So for example, you consider all the possibilities where Helen is in column 1 and the other one is in column 3. In other words, they wouldn't be sitting next to each other, or like in column 2 and column 4, or column 1 and column 4. And then you add all these possibilities.
Not going to lie though, if you're kind of like dumb like me and mix up these 2 words like row and column during the exam, rip.
Oh God.
I mix up that often too. I'm more familiar with periods and groups rather than rows and columns.
Chemistry.
Okay. And next, we finally have a binomial theorem.
Is it coefficients?
Yeah.
Oh boy.
Oh boy.
Wait, I'll remove the present annotations. Yeah.
Oh, I'm not sure whether you guys had this in your syllabus, but like I've never seen a past paper question on like that ever before. But it's in our textbook. Let me just pull it out. Just a second.
Sure.
It was completely new to me once I saw it. Just a second. It was regarding Newton's generalization, and it was about
So you have fractional and negative exponents, right?
yeah, but it's about estimating the number that you get.
Oh, yeah.
I actually have questions. It's like that in the book I clipped it from.
Like I've never seen a question like that in a past paper before, so I was like, what the shit is this? Okay, yeah. Here, for example. Yeah.
Do you send it on the Discord?
Sending it right now. Just found it now. Yeah, it's in session chat.
Find the first four terms of the binomial expansion of.
I mean, this gives you the step-by-step process, but they could, for example, completely skip over B.
Oh, yeah. I see.
And ask
just
for you to come
multiply.
up with X number yourself.
I think usually it's like pretty intuitive, but
I mean, yeah, I just never saw a past paper question like this one, so I thought I would add. So I assume that you guys haven't seen it as well.
I remember doing this like 2 years ago in GCSE, but it wasn't in IB, I think.
Wait, isn't there like a different formula for X?
Newton's generalization.
Yeah,
I
when
don't
you
know
have
formula.
non-integers, there's a formula you can use. It's
Speaking of
basically
which,
just
does that formula only apply if we only have one of the numbers as 1?
I believe so, yeah.
Right? Okay. Otherwise, it doesn't apply. Okay, cool.
It's basically just Taylor series.
I've never done that yet, so got no clue.
Taylor series is like a way of expressing any functions in terms of a polynomial.
Like for
That's cool.
example, I'll actually give you an example on clear alternates. Yeah. So Taylor series just means that you can express any polynomial as a sum of polynomials, and if you take we get those polynomials by basically like, I mean not the polynomials but the constants by like taking derivatives. So like if you take a first derivative of whatever that expression is, c, the first constant disappears out and you get like c1 plus no plus 2c2x and yeah. We'll actually cover that later because like it makes much more sense to use the Taylor series. Like there's not a coherent
Just
like
squeezing them out, in a sense.
yeah. So in as far as we have yeah. Switching to screen.
Oops, just realized I was muted while doing the sign X thing.
So in IB Maths HL, you had like mostly three types of binomial theorem questions. One where you have to find the coefficient of x to the power of something, and which could be constant term, which basically means it becomes x to the power of 0. And the second is yeah, you have like two binomials like given together. Usually, like one of them is what happened just now.
Nice.
You're the only one that can explain that. We don't know.
Okay, coming back, like somehow all the annotations got lost and I got disconnected. But yeah, you have a second type. You have like two binomials being like multiplied with each other. So you have to so one of them will have like a small power. We'll have IB style questions in the next slides of each of them, and then you have like relations between coefficients, like they would give you the value of one of the coefficients, like the the coefficient of the fifth term is they would give you its value, and then that would be enough information for you to find. And properties of binomial coefficient. So it's basically the combination notation itself. So it it is symmetric. It doesn't matter if you start from C from N0 to NR, or from NR to N0. Yeah. And next slide. Okay, so so you can quickly find out the binomial coefficients using a Pascal triangle for small number status, and why the relation with a Pascal triangle also explains why you have like combinations in front of binomial coefficient. So usually, like you have the first part marked as 1, and then from this point to this point, there's like there's one way to reach that point. So you get a 1 1 on both these, and then to get from the top to this point, there are like two ways to get there. So you get 2 over there, and this is why you get like one in all these places, and this actually goes into combinations, because wait, I'll clear it. Red draw, yeah. So you could see that over here it's 1 1 1, because there's one way to get from here to the bottom points, and over here there are two ways to get to the midpoint you see there, and one way, so it follows this pattern, and then yeah. So you see like a similar pattern for or binomial binomial expansions, because wait, close. When you have a plus b to the power of n, you have basically a plus b multiplied by itself n times, and then there now you know the one of the them is like a to the power of n, b to the power of 0. So what we are asking is how we there are total of n a's, and how do we pick those n a's to get a to the power of n, which is basically n binomial n chooser n. But when you have like when it's a to the power of n minus 1 times b, what for the to get the binomial coefficient of such a term, you have to basically find the number of ways n minus 1 is, and 1b could be arranged amongst themselves. So this is another. This is why like combinations come into the binomial sequences. Yeah, clear. Yeah. So this view that I haven't covered as much, so I'd go on to yeah. So the let's do like the first two questions to begin with. We said we shall see. I've tried to cover all those sorts of questions which
What's
come.
a radical sign?
A radical sign is like this is like a radical sign. So what is?
Oh, okay.
Yeah, you get it right.
Is y to the power of 5 also a radical sign?
No.
No, okay. So it's just the square thing.
Wait, how about we start with the IB questions and then move on to the harder ones?
Okay. Well then. Yeah. Yeah, actually, you can see that we have somewhat the sort of question you're talking about in question B.
Yeah, but it's like different because the one I was talking about has a restriction of the x being between -1 and 1 usually, or like the restriction that they give. So you have
That's
to be like,
yeah, because you have
creative.
an infinite series, so there has to be some restriction, otherwise it will
Yeah,
diverge.
exactly. But for example, here it's like quite latently obvious.
Yeah.
Is this a calc or non-calc? Oh, it's paper one. Never mind. Got no space left. To be honest, I think these are the nicest questions that you'll get in the exam.
Okay, so I don't think I can do the last question for A.
Okay. What did you all get as the answer for the third A?
Yeah.
What did you all get for the answer for the third question A?
If I recall correctly, I think it was 16, but like I'm gonna have to check my notes on what I've actually done. Yeah, it's the one that is equal to 3,360, right? I got n is equal to 16.
For A, I got 16.
Can't. One plus x to the power of n. Write down the first 4 terms of the expansion. So that cube minus 9n square plus 14n is equals to 0. So I shall go over the last question there. 1 plus x to the power of n. The second, third, and fourth coefficients form an AP. So we expand just the first 4 terms. The first term is going to be just 1, and the next term would be n1 is n, and it's x to the power of 1. So we are going to get 1 plus nx, and for the next one, n2 is n factorial by n minus 2 factorial by 2 factorial and n minus 1 by 2. So this is with yeah, n minus 2 1 by 2 x squared. Next n binomial 3. So we have n factorial n minus 3 factorial 3 factorial. So 3 factorial is going to be 6, and this cancels out. So we have n minus 1 n minus 2. So we get plus n minus 1 n minus 2 by 6 x cubed. Okay. So I'm going to erase all the stuff.
It's the same as Newton's, no? Basically, because there's a 1.
Well, yeah, it follows for fractional and negative numbers as well. So it's given in the question that the second, third, and fourth coefficients and follow an AP. So we are given that n minus 1 by 2 and n minus 1 n minus 2 by 6 follows an AP. Now, if it's an AP, then it follows that the common difference between, like, the difference between two consecutive numbers is like the same. So we do n minus 1 by 2 minus n is equals to n minus 1 n minus 2 by 6 minus n minus 1 by 2. Okay, then what was up this? Okay, so I'm going to simplify. We get n square minus n, and over here we have minus 2n is equals to on this side 6 n n cubed minus 1 minus. This would be minus 3 n square plus 2n. Now over here I multiply by 3 to get minus 3 n squared plus 3n. Now I'm going to just cross multiply, so I would get so if I multiply this entire thing by 6, this would be 3n squared minus 3n minus 6n, and similarly I'm going to multiply this side by 6 as well, which will cancel this off, and then I'm going to bring it all to one side, minus 3n squared, and 3n squared becomes 6n squared plus 2n and plus 5n, and then on the other side we have 3n squared minus 9n. Further simplifying, we get n cubed minus 9n squared plus 14n, which was what the question was asking for. You can easily factor out and then make it a quadratic equation to solve the rest. Yeah.
Otherwise, because it's a paper 2, you can just graph it if you're feeling lazy.
Yeah, there was a lot of algebra there. Okay. Well, I revealed. Okay, the answers are revealed. Yeah. Okay, it's fine now. over here, you may see this question and this question many a time in IB. The only catch in this question is that the coefficient has to be like it has to cancel out. So we could try 6.17. Chelsea. Yeah, Chelsea, we are doing example 6.17. Basically, in the question, radical sign means that the under root has just to like cancel. It has to just cancel off. So if it's to the power of 5, then it cancels off. Did anybody get an answer? Because you're not supposed to find the actual terms, it's just the number of terms.
I want to say 5.
Close. Could
Like
you
I haven't
explain?
actually done. What I tried was basically since 1 over 5 is already a multiple of 10 in itself, so I like tried to ignore it.
Yeah.
So I just looked into 1 over like x to the power 1 over 10, and it can be like 10, 20, 30, 40, 50. So
Which question are we doing right now? I'm so sorry.
Example 6.17.
Question 6.1?
This one, the one I've inside the blue box.
oh shit, is it 6?
Yeah, it's 6 because it could be
Yeah,
0.
because of y is isolated. Yes. Okay.
Yeah.
Okay. Cool. God damn it.
I'm really sorry,
Continue.
but my connection keeps on cutting off just now. So are we doing?
अभी नहीं. Okay. So for exercise 6. Example 6.32, like I think we have some of those types in IB, where you are like given the coefficients of two terms. Over here it's 3, or they've given a detail less. Yeah.
This is the same question as the one you showed before, actually, now that I realize. Pretty much, at least. With the simultaneous
one?
equations, it's 6.32.
You're getting n as 6.32.
Yeah, no. I'm saying it's the
Oh,
same
yeah.
question with the simultaneous equation that we
It's
made.
similar, yeah. The in IB questions they would like
Do it step by step, I guess. But like
they would give you like just two terms or two consecutive terms, and they'll tell you which term exactly it is instead of, yeah. That's the sort I've seen in algebra. So you can tell what is R over here.
All right. I want to go back into the actual core of the question.
Right now.
I mean, that's up to you, I think. Like, you can do any, to be fair.
What happened?
She was just asking which question we are in.
Yeah, because I got my connection cut off several times just now.
Yeah, we were discussing example 6.3, example 6.32. And
So, would it be a general rule to say that dividing, well, like when you have, for example, in example 6.32, right? When you create like a pair of three, let's just say binomial expansions, like in terms, that you divide the higher term by the lower term and repeat the same for the, for example, third term divided by second term and second term divided by first term. Is that because it forms a geometric sequence, or like, am I missing out something? If that makes sense
it
at all.
gives you a relation of n in terms of r and then you get another relation of n in terms of r. If you like, wait, I'll get. If they are not like consecutive, then the equation you're going to get is not like going to be linear.
Oh, they're not going to be line. Okay, I see. I see. Holy shit, that's cool. And if you were to, let's just say, do the opposite, instead of dividing the third term by second term, and you were to do second term by third term instead, you would still get a linear, technically speaking, wouldn't you?
Yeah.
Okay. Cool, cool, cool. I see. Thank you. And just a question for number 2 on the applications, exercise 6.6.
6.1 you mean? Or this
No,
or this one? Yeah.
this one's fine, yeah. For number 2, do we differentiate it?
Number 2. Okay, this is like
Because can't you find the greatest term if you differentiate it and equate to 0? If that makes sense.
since like since
Because
they
it's
are
like a,
opposite roots, I'm not sure if that helps, but I'll try that. I'll try that later and give you an informed answer. But usually in these sort of questions, uh, uh, the method I actually can't find a drawing tool right now for some reason. Annotate. Yeah,
oh,
I
okay.
found it.
Because like when I thought about it, it's like, you know how you were gonna get a like a really, really long even polynomial, which is probably gonna be looking like a parabola anyway.
Yeah.
Yeah, so like if we just assume that it's a really long even polynomial and we differentiate it, I mean, I guess we can technically find the maximum at the point it reaches when
There's,
we differentiate that.
I mean, it's just like one root or like re repeated 7 times, and I'm not sure if that is going to help you.
But like, okay, let's see if this works. I'm gonna try it.
Okay.
Okay, I don't think it works.
Yeah, the method we usually use is like we get uh, we get like the formula for the r term, and then we write the formula for the r plus 1 term in terms of like an inequality, and then we find like the critical points in, thus we can like find uh, for which our minimum are like this inequality holds, and then that becomes the answer.
I see. Oh yeah, no, I understand that. I just thought like maybe there would be like a kind of a more systematic way.
I mean, this is systematic, but yeah, if differentiation worked, that would have been better. Yeah, but yeah, differentiation is different for like like differentiation won't get you the expansion unless you're using that Taylor theorem.
Hyper eyes. Better explain it. Oh, like expressing in terms of Taylor series. Oh,
But I'm not sure if this will help you because I haven't tried it for these type of questions.
okay, just curious.
Hmm.
I mean, all these questions are kind of new to me, like some of them at least, not all.
Um, if n is an even positive integer, then find the values of x if it may have the greatest coefficient also. Okay, I'll do the second question just to show how to find the greatest term like in a binomial expansion, and I would actually say I'd call it off because we have done through a lot of questions now.
Yeah, okay, sure. I mean, I've got to eat as well, so.
So the expansion is, so we have got 1 plus 4x to the power of 8, and we have to find the greatest term if x is equals to 1 by 3. Now the so the rth term is given by n r minus 1, 1 to the power of something, whatever it is, it will remain in 1, and 8r minus 1, 4x to the power of 8 minus r plus 1, and that is 9 minus r. 4x to the power of 9 minus r, and the r plus 1 term is given by 8, wait, ignore that, 8r 1 4x to the power of r. Actually, I'm wait. So here it's supposed to be r minus 1. Yeah. So we have to find for which r plus 1 term is greater than rth term, and if we find like the critical values where like for which this inequality holds, then we can actually like find which term is like the greatest. So we've got 8 r minus r minus 1, 4x to the power of r minus 1 is it's greater than 8 or 1 to the 4x to the power of r, and if we expand that out, we'll use a different color. If we expand that out, that is going to be 8 factorial r minus 1 factorial, 9 minus r factorial, 4x to the power of r minus 1 is greater than 8 r factorial, 8 minus r factorial. We can cancel off 8 factorials on the both sides. I'm going to rub more. Okay, I'm going to know 8 greater than 8 factorial, r factorial, 8 minus r factorial, 4x to the power of r, and then on this side we have r minus 1 factorial, 9 minus r factorial. The 8 factorials we can cancel off, and r factorial is r times r minus 1. This is r times r minus 1 factorial. So over here also it cancels off. And then wait, I forgot to write it's 4x to the power of r minus 1 here. There's a lot. Okay. 8. So 9 minus r factorial is the same as 9 minus r times 8 minus r factorial. So we can cancel off to write 9 minus r here. And then over here, okay, we are actually going to cross multiply here because things are getting messy. Just cancel off like that. R times 4 to the power of r times x to the power of r 4 r minus 1, and on the other side we have 4 to the power of r x to the power of r 9 minus r. Take a look at the question. What was the question again?
Find the highest, basically find
If
r
x is
for
equals to
which this
1,
is true right
okay,
now.
so I think at this point we can actually plug in x is equals to 1 by 3. I think we can plug in x is equals to 1 by 3 now. So this becomes r 4 by 3 to the power of r minus 1.
Minus 1.
And then 4 by 3 to the power of r 9 minus r. Now I'm going to take in order for the 4 by 3, since like the exponent base is the same, I'm going to carry this over to the, yeah, it's coming out well now. Oh, you can see that 4 by, using the color again. So 4 by 3 to the power of r minus 1 is the same thing as 4 by 3 to the power of r times 4 by 3 to the power of minus 1.
Yeah, times 3 over 4. Yes.
So we can cancel off and write it as 4 by 3 to the power of minus 1. And you can see 4 by 3 to the power of minus 1 is just 3 by 4. Okay, we are getting there. So 3, so I'm continuing it above. 3r by 4 is more than 9 minus r. 3r is more than 36 minus 4r. We don't have to get an integer value for this because it's an inequality. We just need to get a critical value. 7r is more than 36x. So if the r plus, so our critical value is going to be r is equals to 6 for which this integer, we need to get an integer values. That's why when it's r is more than 36 by 7, we are going to take the next integer.
Oh, yeah. Okay, makes sense. Cool.
So yeah, it's r is equals to 6.
That's really cool.
Yeah, you can check the book for more questions like this.
Is this from the Permutations and the Combinations book that I uploaded, or is it different?
No, it's from the set of Indian books I sent.
Oh, from those. Okay, yeah.
Yeah. So is Hachi even there?
I don't think so, to be honest.
I'm here. I'm just AFK.
Yeah.
But yeah.
So that was quite a session. I hope I learned something from this, and I hope everybody learned something from this. I'm going to call it off now.
Yeah, that was good.
That was really helpful, to be honest.
Yeah. Yeah, I also got the indication that I need to practice these more. Like
Yeah, definitely.
since quarantine, I've been really like focusing on calc only.
I haven't done any maths for a while, to be
The only
honest.
thing that I've realized is that I need to work on combination questions when people are in circles.
Yeah.
It's like a cross.
Dude, Jem, when are you joining Helper Lounge?
Huh?
Become a helper and join Helper Lounge.
I think he applied.
Yeah.
I'm kind of confused. Hold on. Is it in the join lounge?
Oh, no, I'm just saying, when are you going to join?
Oh, when? Well, whenever they respond to the application, I guess.
Took just a week for me.
Oh, there's a hentai server, by the way, that Em and Chelsea. There's only
Hold on.
literally people on there. Do you want to invite link?
Yeah,
Hyper eyes.
sure.
Did you get like the explanation for why the Pascal triangle like follows the the binomial pattern or the combination pattern.
Yeah, no, that was quite clear. It was the amount of ways that it can basically reach that place,
Yeah,
like the amount of different
yeah,
ways. It's basically the count of that.
that I got from the book you said.
Yeah, I
So
didn't know
it
that.
was,
That was completely new to me.
yeah, that was new to me, but that made a lot of things clear for me because although I got
Yeah, same.
although I got the combinatorial argument, I didn't use the Pascal triangle.
I mean, for me, just like made it more clear. I still don't know how. Like, I mean, I haven't actually used Pascal's triangle at all since I've learned it, to be honest. But it just like now, like it makes sense on why this works.
But there's
I remember like the first 5 lines of Pascal triangle.
I mean, I can illustrate it right now if you want. Hello?
Did he accidentally leave again?
I'm not sure. Hechu, do you want me to draw it for you and like actually explain why?
Wait,
Like,
what is it?
the Pascal's triangles on like the numbers, the count, I guess. What he meant by that.
Okay, sure.
Because you said you remembered only
Oh
5
no,
words.
I know
so.
how it works.
Oh, okay.
Yeah,
Is Ariane here?
Pascal triangle.
yeah, I'm here.
No idea.
I was listening.
Oh, okay, cool.
Hechi?
Yeah, it
No,
was.
this
I
was
got
really
a
long.
headache actually.
Well,
I'm gonna go eat now.
Yeah.
I've got an English essay to do as well.
I always work on English.
Dude, it's my last assignment and I've been procrastinating.
Understandable. Well, yeah.
Thank you guys. That was some really POC stuff.
I would like to do another session on
Nice.
combinatorics
Is-
once I've done the problems in these books because I haven't. Yeah, some of these look kind of not familiar enough to me either.
Yeah, these questions are PPGs.
Yeah, these questions were kind of PPGs, I agree. Some of them, especially the first few. That was just, I'm like, oh shit. By the first few, I mean the circle ones.
But- yeah, yeah. Anyways, yeah.
All right. Thank you guys. I'll see you later.
See you.
Yeah. Bye.
Bye.
Bye-bye.